lesson P.5 is solving equations numerically and graphically. For the most part, it's using methods you already know to solve, and most of these equations we're going to be looking at are quadratic type. So it's really a chapter you did in Algebra 2 last year, all in one lesson this year. Okay? So, we're solving these quadratics for the most part. We're going to start with the, well, in my brain, the easiest one, which is factoring. The one that we usually probably most appreciate. We love when things can factor. So we're going to look at example 1. You guys remember the idea of the zero factor property? I mean, the gist of it is if two items multiply together to equal 0, then one of those two items must be 0. That's the gist of it. Okay? Now, there it is. Let A and B be real numbers. If A times B equals 0, then A equals 0 or B equals 0. So that's the idea. If we get an equation equal to 0, we can factor it into two factors that are multiplied together. Then we can set each one equal to 0 and see what we get there. Thoughts on example 1? It says to solve it by factoring. What's the first thing you should check? Does it equal 0? Okay, so always check, does it equal 0? If we are, factoring. And I'm even going to put a note over here, must equal 0. Okay, thoughts about factoring this one? You're jumping right in, right? We're all in on this one. Oh, yeah. We're not babying you with the easy factoring. What's the challenge? Why is no one talking to me? What do you guys not like about this one?
I haven't factored.
It's factoring.
In a year.
Nobody likes factoring.
6 months.
I'm still half of this.
Oh, yeah, that's it. Oh.
Okay, so ideally, now I'm going to end up erasing this here in a moment, FYI, because of this particular problem. So ideally, we're trying to factor this into two parentheses, right? My first question, before I even do that, though, should be, is there a GCF? Is there a greatest common factor? No. Now, in an easy problem, this first term is x squared. And if it's x squared, we could go ahead and break this into x and x. But I said I'm going to erase this because, does this work in this case?
No, it doesn't.
No, because there's a 2x squared. Now, a small few of you may be willing to go the guess and check route with me. Usually, I make a lot of you mad, though, if I go the guess and check route here. Because it just, I don't know. Everyone gets frustrated. They don't like the guess and check. You guys would rather use what method? Product of AC?
Where you split.
Yeah, where we split, see? Okay, so.
Remember.
I never said I didn't remember. I said I didn't like to do it.
Remember why
Okay, now, when I say product of AC, realize that is based on the form ax squared plus bx plus c equaling 0, yes? Okay, and there's other ways to do this. Like, I'll be interested to know how you ladies factor this back there. But if we're using product of AC, what are my A and C? 2 times -2, which is -4. And we need a sum of B. What is my B value? -3. Okay, so two numbers, multiply to be -4, add to be -3. Kylie says -4 and 1. Now, because this is product of AC, I can't just put -4 and 1 in my parentheses. It doesn't work like that. Only if it was x squared for x and x. So, I teach this if you need a method to split your middle term. So my middle term of negative 3x is going to split into these two pieces, negative 4x and positive 1x. You can write it either way. Do you guys have a preference? I'll go negative 4x plus 1x. Your other two terms carry down. So 2x squared carries down. Minus 2 and equals 0 carries down. Now we've got 4 terms. So we can do what? Cut it in half. So we're cutting in half there, and we're looking for our GCF. GCF of the first two terms. So 2x squared and 4x both divide by 2x. So I'm going to factor 2x out front. When I divide both pieces by 2x, what am I left with in parentheses? X minus 2. Then we repeat the process for the second half. 1x minus 2, or in other words, x minus 2. GCF, greatest common factor.
X.
Do they both have an x in common? Just a 1. Now, do me a favor, don't tell me nothing. There is a GCF, and I'm going to call it 1. Now, you need to factor something out here. We need something here. You can't just leave this a blank. So I'm going to say it's a plus 1. Now, when I factor 1 out, does anything change here? X minus 2 divided by 1 is still x minus 2 in those parentheses, and it equals 0. In algebra, I always teach, we know we were successful or we're on the right track because my parentheses of x minus 2 match. And so now we can factor this into 2 parentheses because my matching parenthesis is x minus 2, yes? So I can factor out an x minus 2. And then what are my remaining pieces that are left when I pull out the x minus 2?
2x plus 1.
There's a 2x plus 1. So now it factors into 2 parentheses. Now, if you could see that from the beginning using guess and check, I sometimes throw that in at you, you can do that with guess and check. That one is very doable with guess and check. And I've got 3 people in here that I didn't have for Algebra 2, so I don't know necessarily how you guys do this, but am I done here? No. We have 2 pieces multiplying to equal 0. Now my job is to set them both equal to 0. So I'm going to set x minus 2 equal to 0, or 2x plus 1 equals 0. On the first one, if it's x minus 2, we're going to add 2. On the 2x plus 1, I'm going to have to subtract 1. And I'm going to end up with answers of x equals 2. And if I add 1, then I'm going to have to divide by 2, and we'll end up with, no, I'll go with negative 1/2. Because it was 2x plus 1, right? Nope, that was my mistake. So we have answers of 2 and negative 1/2. And yeah, because it would have been 2x equals negative 1 divided by 2. Sounds familiar somehow or another? Do you have a method that works for you? If you don't like my method, do you know what you want to do? Okay? And as I said, there's nothing wrong with guessing and checking on this one. Because when I say guess and check, what I would be talking about is just setting up my 2 parentheses. I know 2x squared is going to break into 2x times x. I know minus 2 has to be some combination of 2 and 1 and a negative and a positive. So it's just a matter of finagling it all to make it happen. Okay, questions here? No? Okay. This next one, the name is probably going to sound unusual, but I promise you've done this before. Okay? Solving by extracting roots. I don't feel like we usually call it that. A quadratic equation, okay, this is just kind of a reminder, written in the form ax squared plus bx plus c equals 0, can be at least. But we're looking at slightly different forms. So how do we solve something? 2x minus 1 squared equals 9. And I will say there's not one right way to do it. There's a way I want to go to teach a skill here, review a skill. Do we have any thoughts? Square root. You know what he means, square root? Yeah. Let me throw, if this equation was x squared equals 9, could you solve that?
We take the square roots of both.
Yeah, you take the square roots of both sides, right? Is this something squared equals a number?
Yes. Yeah.
So can we take the square root of both sides? Yes. And that's what we are looking at doing there. So we're going to take the square root of both sides. If we take the square root of the left, we're going to take the square root of the right. What is the square root of 2x minus 1 squared?
2x minus
2x minus 1. What is the square root of 9?
3. Way easier.
Is that all you're going to tell me there?
Well, you gotta subtract 1.
Oh, pause,
You gotta add 1. Oh, yeah.
pause. I'm not happy with what I have written right here.
Negative 3. Plus or minus.
Oh, dang it. Forgot about that.
Okay. Now that I've effectively stumped everybody for a brief
Now I
moment.
gotta erase my whole
know.
answer too. What the heck?
Okay, keep in mind, we are solving quadratics today. These are x squared equations. That power of 2 means there are usually how many answers?
2.
Most quadratics have 2 answers. Occasionally 1, occasionally none, but most have 2. So when you take the square root of both sides of an equation, you have to take into account the positive and negative solutions. So we always say equal to a plus or minus of that value. And if that was a number we couldn't take the square root of, we'd just say plus or minus the square root of whatever that number is. Now, basically, how many equations am I solving at this point?
2.
We're basically solving 2. You can work it in this form if you're comfortable with that and just have 2 numbers on the right, or you can set it up as 2x minus 1 equals 3, or 2x minus 1 equals negative 3. I'm so impressed we remembered the square root, but we forgot the plus or minus for a bit. Okay, so 2x minus 1, we're going to add 1. I'm going to get 2x equals 4. So x equals 2 on that one. I'm going to add 1 over here. Negative 3 plus 1 is negative 2. Divide by 2. Answers of 2 and negative 1.
That's what I got.
Okay.
I thought it was 6.
As always, how can we check our answers if we need to?
Plug it back in.
Plug them back in, yes? And in this case, because you're going to take that quantity on the left and square it, both are going to work. Okay. That sounds familiar, yes?
Yes.
Once we dig into it. Again, I wouldn't call this solving by extracting roots. That is what it is, but we usually think of it as just taking the square root of both sides. Okay. We're okay then. Okay, because that leads us into the bottom. The bottom is one of our favorites, I know. We all love completing the square. No, not the case. Okay, well, we worked out last year in Algebra 2, so it's not brand new by any means. To solve x squared plus bx equals c by completing the square, add b over 2 squared to both sides of the equation, and factor the left side of the new equation. Once you get that left side factored, then we're going to go back to what we just did in solving by extracting roots. So solving by taking square roots. Now, some highlights here. First of all, in order to do this, your equation has to start off, and I'm going to kind of put some steps over here. My step 1 is going to be that I need my equation to be x squared plus bx equals c. Two important things to point out. My constant is on the right, and what's in front of x squared? A coefficient of 1 and only 1. Notice in front of x squared there is no a value, is there? So that is key piece of information as we complete the square. So let's look at our problem. Do I have step 1 done? No. Okay, what should I do to work with step 1?
Subtract 17.
Okay, we definitely want all constants on the right. I would always make that my first step. So in this case, subtract 17. So then I have 4x squared minus 20x equals negative 17. I do tend to leave a purposeful space when I'm completing the square. Now, I'll be honest, we still have another step before you have to have that space. So you don't have to get too mad at me about your erasing, because they're all huffy puffy up here. Okay. Is step 1 done? It's not. Big not. It's not done. I have my c value over. That's good. So I have an x squared term plus an x term equals a number term. But
You still have the a.
I'm not allowed anything in front of x squared. How do we get rid of that 4 in front of x squared? Divide by 4. If we're going to divide that term by 4, everybody divides by 4. So, the left side cleans up nicely, right? X squared minus 5x, I am definitely leaving a gap now, equals negative 17/4. Got to work with a fraction. It is what it is. Okay. Now have we finally completed step 1? Okay, and sometimes step 1 is a lot easier. That was the more complicated version of step 1. Okay, step 2 is we're going to add b over 2 quantity squared to both sides of the equation. So I'm just going to write to both sides. So, get that written out and then start thinking, what is b?
5.
And I'm going to be specific, and we need our current b, yes? You don't want to go up to the original problem. We want b from our current form. And so, b is negative 5. So that means we're going to do b divided by 2 quantity squared. So what is b divided by 2? It's negative 5 divided by 2. And I'm taking this in baby steps. And then, what is b divided by 2 squared? Well, if I take negative 5 halves and square it, I want a fraction answer, not a decimal answer. Five times 5 over 2 times 2? 25/4. And that value will always come out positive then, right? Okay. So, That right there, b over 2 squared, is what we're going to add to both sides. So we're going to take this, and we're going to add it right here on the left, and we're going to add it over here on the right. So I took this 25/4, and I'm adding it there, and I'm adding it there. Okay. That was step 2. Questions about step 2? Okay, step 3 is going to be factor the left side of the new equation. So I always just say factor the left side. The idea when we factor the left side is that we are factoring into 2 parentheses. However, when we factor into 2 parentheses, we're factoring into 2 identical parentheses. And so the step we usually jump to is that we usually say, debating how I want to do this, parentheses squared. Now, if you, as we begin, want to kind of think, okay, I want to think parenthesis times parenthesis for a moment, you can. But I usually just jump to straight to parentheses squared. Okay? Think with me. X squared breaks up into x and x. So if you're going for 2 parentheses, it's x and x. If you're going for 1 parenthesis, it's just right there. Now, the shortcut here is to ask, we need the square root of x squared in the front. We need the square root of 25/4 out back. What is the square root of 25/4? 5 over 2. Square root of 25 is 5. Square root of 4 is 2. So 5/2 is what goes in the back of each parenthesis. Or in other words, it's going to go in the back of that parenthesis. Now, if these 5/2 have to together multiply to be a positive and add to be a negative, what do we know about the signs? Both negative, which is why we can say x minus 5/2 quantity squared. Now, I'm going to tell you guys, it's pre-calc. Normal situation, I'm not going to write that side-by-side view. Okay? I don't even know if I wrote it in Algebra 2. I think I did sometimes, just trying to help understand, because I get people say, well, what about the 5x? We never touched the 5x. Well, the 5 is if we FOILed this out. It would be your outsides and your insides. And your outsides would be a 2.5x. Your insides would be a 2.5x. Excuse me, negatives. A negative 2.5 and a negative 2.5 is going to be a negative 5. Okay? Let's clean up the right. Oh, and by the way, the other thing, this sign, this minus sign, is always going to match the sign in front of your B term. Also, no coincidence. Guess what? How did we get 25/4? We got 25/4 from squaring negative 5/2. That will always match as well. Okay? Now, back to what I started to ask. What is negative 17/4 plus 25/4?
Yeah, 8 over 4, which is 2.
Okay, 8 over 4. I'm going to go the 2 route then. Okay. We have one more step. Or generally, we have to finish this problem off. Generally speaking, how are we going to finish this problem off? How are we going to solve it? Using what method?
Split.
Can we square root like the problem above? That's the whole reason I introduced solve by extracting roots. Because right here, we're doing this right here. So I generally over here, I don't say solve by extract units, I say solve by, I usually say solve using square roots. There's what I say. That makes more sense. So solve using square roots. So I square root the left and square root the right. What is the square root of x minus 5 halves squared? X minus 5 halves. What is the square root of 2? Don't give me a decimal. Leave it as the square root of 2. And plus or minus. I'm starting to feel let down that you guys already forgot about it. Now, we're going to leave this as an exact answer. So no, we're not going to go decimals and try and add this square root in this fraction. But go for the basics here. How do I finish this off? How do I get x by itself? If it's x minus 5 halves, we're going to add 5 halves. If we add 5 halves on one side, we add 5 halves on the other side. As I add this, good mathematical form would be, say, let's put the plus or minus in between the two pieces. And so since the plus or minus is in front of the square root, typical good mathematical form would be to say 5 halves plus or minus the square root of 2. How many answers do I have on this problem? Do I still have my 2?
Yeah.
Yeah, I have 5 halves plus the square root of 2 as one answer, whatever that might be, and I have 5 halves minus the square root of 2, whatever that might be. Okay? Completing the square is not something that goes away. It randomly comes up in solving. It also randomly just comes up as parts of other problems. So it is something you have to work to master. It really is. Okay? Now, I don't think this was the easiest version of one by any means. There is it. You had to deal with fractions. You know, there's an a value we had to get rid of, and then we had to deal with fractions and not a perfect square. So it was kind of a messy one. It's a good example. Okay. Backside. I don't know. Do we like or hate this version? I don't know. Quadratic formula. My step 1 is usually to try factoring something. Okay, that's my step 1. I look for factoring. That's what I'm going to hope works because that's the easiest in my brain. If factoring doesn't work, maybe it's a special case and I can solve using square roots. I might try that. Okay, completing the square is more of a special case scenario. Okay, I might use it before quadratic formula. Not necessarily. It's more of a special case formula, but it's one we have to have at times. Quadratic formula. When all else fails, what will definitely work? Quadratic formula. Okay, every time. So, solutions of the quadratic equation, ax squared plus bx plus c equals 0. So notice what has to happen here. It's that ax squared plus bx plus c has to equal 0, and a cannot be 0. If a is 0, then it's not a quadratic equation, so we can't use quadratic formula. And they are given by this formula here. Look familiar? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, let's practice. Should be old news, but let's practice. What's step 1?
Equal to make equal to 0.
Yeah, right now it's not equal to 0, is it? So how am I going to make it equal to 0?
5 both sides.
Subtract 5 over. So 3x squared minus 6x minus 5 equals 0. Only because it's our first one. Not that I make a habit of doing this with pre-calc. But what are my ABCs? Okay. A is 3. It's in front of x squared. B is what? -6. It's in front of x. And C is -5. It's the constant added or subtracted at the end. Okay? Are you trying it? Okay, x equals negative of b. What's the negative of -6? 6. Plus or minus the square root b squared, so -6 squared, minus 4 times a is 3 times c is -5, all over 2a, which is 2 times 3. Okay. I do expect to see some steps. I know we'll all show different amounts of steps. I understand that, but I do expect to see some steps. 6 plus or minus, and let's clean up under the radical. What is -6 squared? And it's a positive 36, correct? Okay, I think, I hate to say it on the quiz, I saw some people get caught by that, where, what was it, -2 squared was -4 for some of you, something like that. So beware, when you square a negative, it has to become a positive. Let's see, 4 times, I don't know, I multiply my numbers and then worry about my sign. You do it how you want, but for me, like I see 4 times 5 is 20. 20 times 3 is 60. I see that there was a minus times a negative, which makes it a positive 60. Here's the deal. Did you get plus 60 your way? Okay. 36 plus 60 is going to be square root of 96. Now, occasionally, we'll take these into decimal answers. More often than not, I feel like we leave them in radical answers. So we leave them in some variation here. While this is equivalent to the final answer, I would not say it is in simplest form. I can't cancel the 6's, at least not right now. And my reasoning for not canceling the 6's is because the 6 on top is married to the square root of 96. It's added or subtracted to the square root of 96. And when something is added or subtracted, it's not a factor, so we can't cancel it. Might be able to do some canceling with the 6's later, but not yet. Unless, of course, I guess we break it into 2 fractions. But what about that square root of 96? What? It's breakable? 96 itself is not a perfect square. But if you grab that calculator and start playing, you're going to find that 96 is divisible by a perfect square. 96 divides by 16. Does this sound familiar? I'm just going to kind of write it right up here that 96 is 6 times 16. So that is important because 16 is a perfect square, right? So we still have 6 out front, plus or minus. Now, if this is 16 times 6, the square root of 16 is 4. That 4 goes out front, the radical. And then 6, I can't take the square root of, so we leave it under the radical. All divided by 6. This problem has lots of 6's in it, doesn't it? Now, we can do a little bit of simplifying at this point. There's 2 different ways we could write our final answer. I see 3 terms here. All 3 terms divide by a number. So 6 here, the 4 on the outside here, and the 6 here can all divide by 2. if I divide them all by 2, I could rewrite this as, well, 6 divided by 2 is 3, plus or minus. So 4 square root of 6 divided by 2. You're just dividing the outside number. 4 divided by 2 is 2. Square root of 6 stays. And 6 divided by 2 on bottom is 3. That would be one possible way to leave an answer. Okay? The other possible way is to break this up into 2 pieces. Meaning this denominator of 3 goes under both pieces, right? So the other way would be 3 divided by 3 is 1, plus or minus 2 square root of 6 divided by 3, 2 square root of 6 divided by 3. Those are equivalent answers. If you plugged them into your calculator and checked them, you would find them to be equivalent. I would take either or there. Okay. That's review, yes? I'm not throwing new stuff at you, I promise, not with this stuff. You just got to dig deep for all this to put it into one lesson. Okay. Last thing we're going to do is we're going to solve graphically. Okay? Solving graphically means we have to graph it. Enough said, right? The solutions of an equation, when given a graph of the equation, are the locations where the graph crosses the x-axis. Did you catch that? So when we're trying to find the solutions, it's where the graph crosses the x-axis. Okay? Now, you'll notice here it says to do this, we're going to use our calculator and the trace feature. I'm also going to teach you a little bit more than just trace, because I'm going to teach you how to find the exact value. Okay, so what's the first thing you're going to have to do if we're going to graph this? Do you know what this graph is? You don't know what this graph looks like, do you? So we're going to have to graph in our calculator. In order to graph in our calculator, it needs to be y equals. Well, we don't have a y in here, but as long as your equation is equal to 0, basically you can take that 0 out and put in a y. So you're going to graph the equation y equals x cubed minus x minus 1. Any chance everyone happened to bring their calculator with them today? 50-50 shot, right? Any chance I'm prepared with the Elmo? No. Hey, it helps if you turn it on. I even thought to myself, am I going to need the Elmo today? I don't think I will. Okay. So, first things first, you went to your y equals screen, which y equals, to get to this screen, you're going to that top y equals button right there, yes?
Yeah.
In case we've already forgotten how to do some of this stuff, or we weren't here. Then we're going to type in x to the third minus x minus 1. Remember, the x button I suggest you use is this right here. So this xt theta n, I'm going to type x. The exponent button I suggest you use is the one over above the division bar, or above the division sign. It's a little caret, yes?
Yeah.
I say that because I went one year, I don't know, I went half the year and found out someone was using the x squared button the whole time and just changing the exponent. So, just, you know. So x to the third, you will need to arrow out of that exponent before you type in minus x minus 1. We got that part done, right?
Yep.
Okay. In order to graph, I would suggest, I don't know what your screen was on last, but we graphed some funky stuff, didn't we? So my routine is before I hit the graph button, I always go into Zoom and either arrow down to number 6 or I just hit 6 because that will take me back to a standard screen, Z standard. So I hit 6 and it automatically starts graphing for me. And hey, I have a little squiggle. Do you have a little squiggle? We should have the same little squiggle, I hope. Okay. So with that in mind, how many solutions are we going to have? Where are my, okay, back up. Where are my solutions? Where my graph crosses the x-axis. Do you remember the word zeros? Okay, we're trying to find our zeros. Okay, the graph, where the graph crosses the x-axis. How many times does my graph cross the x-axis? Only once in this problem. So I'm only going to have one solution. But we've got to figure out where that solution is. Okay, that's my goal. Now, with this in mind, you'll notice there it said use the trace feature, yes? Trace, and I'm going to have to go quickly here. I can arrow over, I talked about trace previously, didn't I?
Yeah.
But does it give me exact? No, I can tell I'm close to y equals 0 and I'm at 1.36. Close, but not quite. You could zoom in. Remember, I have to enter around it to zoom in. And when I zoom in and hit trace again, I can get a little bit closer. Like right there, I'm at 1.32575. That's really close, guys. Now, how do we get an exact answer? Okay, I'm going to go back to my Zoom standard. We have a way to get an exact answer where I'm not just guessing. Okay, in the Calc menu. Calc menu is above the Trace button, yes? Hit second, Calc. Am I running out of time today? What up there will help me find what I need? And that is 0. So I'm going to go down to 0, and I'm going to hit enter. Now, the calculator guides me. It's asking right now, left bound. So I just want to make sure my cursor is to the left of where we cross through the x-axis, which it is. And then I'm going to hit enter. And now it's asking right bound. So now I'm going to move my cursor to the right. So in this case, it happens to be above, where my graph crosses through the x-axis. And I'm going to hit enter. And now it's asking for guess. So I go back to where the approximate crossing location is and hit enter. Notice now it says 0. That is my official answer. And by all means, I'm obviously going to have to go through this again tomorrow and make sure we understand the graphing part. Do the homework. Attempt the graphs. See what you can do. We'll work with this tomorrow. I do have on the homework written up there, 2, 4, and 6, just factor. I think they say factor and then confirm graphically. You don't have to confirm graphically, unless graphing is how you're supposed to do it. Okay? So, I'm going to write the answers up here and everything before I stop this, but give it a try. We'll tidy up loose ends tomorrow.
Have a good one.
Thank you, you too.